Hey, look, my ring no longer glitches. The bit of cream worked wonders. So there you go, one non-glitchy ring. So stay tuned and we'll see what the problem was. Well, here you have it, folks. This is the little single AND gate that came in the last post bag, and as you can see, it doesn't quite fit the board. So I'm just bodging it on so that no legs get shorted and that I can get to the pins. So it's just a bod's job, and it's just a way of connecting to that board. But a bit of light music. There you go, bodged on. Job's a good one. Well, I'm going to add a little gate to the board. Oh, I hope that's better. Right, that's the original. A little blue wire there is the feed to the display. What I'm going to do is going to lift that off. And I'm going to solder that to the two inputs. Which is those two there. Needn't bother putting pins on really. But they will help with connecting the scope and that when we have a look at what's happening. Right, so that's the input connected. I got some more wire. Right, I've got some red and black wire. Got the squishy ends. Well, looking here, I can see that the yellow trace is the input waveform and the blue trace is the output waveform. You can see from the cursors that the signal going in to the LED array is a 5 volt signal, whereas what's coming out the ESP8266 they say is like a 3.5 volt. So that's giving us the headroom that we need. Where here we can see output at a distance, so you can see the whole ring. The blue dot still going round, but you see it's still glitching. Even though I've just demonstrated that the voltage going into the LED strings is stable. Well, not stable, but it's a 5 volt signal as opposed to the 3.5 volt signal coming out of the ESP8266. So putting the volt level converter on hasn't improved matters. It's just made it less jittery, but we're still running slightly at about 5 volts, which is the right voltage. So I'll stop. Well, just to compound the issue, here is a 60 LED ring that I made in the past when I showed my first 360 degree clock, and this is the same board driving it, and it's being driven at the moment at 5.2 volts and also via the level shifter. So if I turn on the other camera, you will see the yellow trace is the input, or the output from the ESP2866, and the blue trace above it is the output from the AND gate. And as you can see, 3 volts, 3.5 volts or so, 3.3 volts going in, and a pretty solid 5 volts coming out. It kind of hints that there is something wrong with the LEDs in the big ring. We might have to investigate further. And here we go. Removal of the ring front yet again. I won't bore you with me unscrewing the whole of this panel in the dark. Well, I don't know if this could be the issue. As you can see on this, there is a 75 ohm resistor, and sorry about me getting out of focus. I'm trying to hold a little microscope in my hand, which is why it's wibbly wobbly, and a smoothing cap above it. So not sure if that is the issue. They all have it. This is, it will focus, a working ring, still got 60 LEDs, but as you can see, there is a decoupling capacitor on every chip, but there is no resistor. As you can see the track going round, I think that's the 5 volts coming in, and it's going to every one, and that's the only difference. So do I take my ring apart and remove or short all those resistors? Well, I thought I'd start by looking at the 60 LED ring, the little one that worked with no issues whatsoever. As you see, DN's connected to D in and D out to D in, D out to D in, etc. And yeah, this is the first 3 of the 60 LEDs. And you can see the 5 volts comes in, and we have 100N effectively across the first LED, 100N across the second LED, across the third as well, as per the data sheet. And as you saw earlier, this ring runs very happily. Now let's bring up, right, this is the big LED ring, and these are the modules. Each module is then wired to the next module and to the next module, So that's the 5-volt pin on the module, the ground, and then there's a D in pin and a D out pin. So, but if you look at it, there is a resistor and a capacitor across the capacitor is across the chip. I'm assuming it's 100N. You can't tell, so without taking it off and measuring it, so I just guess it's 100N. But 75 ohms. That's a stupid value. 10 ohms might be stupid, but I can see what they're trying to do. They're trying to filter the 5 volts to give it a nice stable 5 volts. But each LED in here at maximum brightness can pull 20 milliamps. And Ohm's law will tell you that as you pull voltage current through this resistor, the volt drop, there will be a volt drop across it. A few little calculations based on 20 milliamp per LED at full brightness. You can see that with 75 ohms times 20 milliamps, the volt drop across it will be 1.5 volts. With 3 LEDs on, so you're looking at 60 milliamps, you're looking at a volt drop of 4.5 volts, giving the LED only half a volt to work on. Now, with the WS2812B supply range from the spec sheet as 3.5 to 5.3, from this we can see that the max current we can provide to the LEDs is less than 20 milliamps with this board, because the chip itself takes a little current. And now you know why the ring was glitching to hell. When the ring was set to 0 to black, apart from the blue LED, the only one that could possibly glitch was the blue one, because it was going all over the place. But all the other LEDs were turned off, so it didn't show that much. But as soon as you turned them onto white and even dim, you were pulling the supply rails down. When you go to update the LED, the voltage across the LED is dependent on the last signal that it got as to how much current it's pulling because of the LEDs it turned on. So what supply voltage it's getting. So when they were set to 0, of course, there was almost 5 volts across the chip, and it quite happily took its 0 and passed on the next bit of data. But if that one was set to, say, 50% white, that's going to be about, I guess, 30 milliamps. And so the supply line is going to be lower than the 3.5 volts specified. So, each time you set a new output into the LEDs, its supply rail changed. No wonder they were glitching. It was ridiculous. I suppose the Chinese company had the PCB, they had the chips, they had the capacitors. They didn't have a reasonable component to put in here, but they had lots of 75 ohms, so they just stuck them on. Or, typical QA, someone didn't check it and they put 75 ohm on when it might have been 7.5 or something. But yes, it's a stupid value, and that's why it glitched. And of course, silly me, I didn't look at what that value was when I looked at the boards. As you don't, you expect them to work. Right, we are going to what doesn't help is there's a huge delay. See that? watch the two screens. You try soldering like that. It's lagging so far behind, I can't see what I'm doing with it. So, you get the idea. That's what I'm going to do. And now I'm going to crack on and do it to the others. And I don't think I'm going to bother showing it or filming it, because I'm sitting inside the ring and it's on my chair, and if I move, it moves, and it's just awkward. So we'll come back when I've gone round and done all 60. Catch you in a bit. Well, there you go. There you see a happy ring. Little blue light running around, no colour changes, nothing happening, no glitches. One happy ring. If you can have a happy ring, that is. Well, if you like what you see and you want to subscribe, click that subscribe button, hit the bell for notifications, and I'll catch you on the next one. Bye for now.